Hello, everyone. How are you? I hope all are doing good. Okay, today the last session I explained assembly language instructions, different set of the problems related to the assembly language instructions, right? So LDM, LDD, then how the loop will run, how the JP jump it is equal, how the jump everything will run. Now the student asked, sir, explain the CPU what is that? CPU architecture. So, what is the CPU architecture and one human model and fetch, decode, and execute. And what are the different types of register and what are the different types of cables and what is the meaning of interrupts and what is the meaning of one pass assembler and what is the meaning of two pass assembler and another one again I'm going to explain the one problem related to the what is that yesterday's the same type of the not same type of question the type of question along with logical shift and exa bit related. This video will be a bit long. Okay, you can go through it. I think it will be useful for your board exam. So now I'm going to share the screen. As of all of you know, so in the who's the brain of computer? The brain of computer is, as we know, that is CPU, right? So here in your pick 1 second. Yes. So it's this brain of computer. Each human being having the brain. What is the purpose of using the brain? It is going to what is that? It is going to compute the all the data instructions like in the cover CPU. What is that? In the computer also we have the CPU. What is the meaning of CPU? As we know, these are all the full form central processing unit. So what are the units inside the CPU? So we have CU control unit, we have ALU arithmetic and a logic unit, and we have the registers. So first I'm going to explain what is the meaning of CPU. CPU is the brain of computer. It executes all the instruction from the programs, and it is going to process and it's going to control all the operator in the systems. So it is that's why it is known as the brain of computer. Okay, now I'm going to deal with what are the units. First is control unit. The name only it is there, control. What is the meaning of control? It is going to control all the operations inside the CPU. So this is the topic comes inside the computer hardware. In that we are dealing with the CPU. In that we are dealing with the components. In that the first one is control. It is going to control all the operations and it is going to send the signal, control signals from where to where, from where, sorry, from to where, and it is going to manage the fetch decode cycle. You must know that this is very very important point. The control unit is going to manage the fetch and decode and execute. It is going to fetch the instruction and it is going to decode and it is going to execute. Okay, now example, reality type example. If you want to cook one meal, so what is that? You take all the recipes. It is known as fetch. You keep fetching all the recipes and decode. And you are going to decode means at what time you are going to put the recipes. Once it is all the things are kept in, then you are going to execute. You're going to prepare a kitchen. What is that? Your food, right? In the kitchen. That is a fetch, and it is going to decode, and it is going to execute. The name already is there. Okay. See, the CU is like a manager giving instruction to the workers. Reality example. He act as a manager, and he is going to send the control signals here. Here is to the workers. Okay. Next is arithmetic and logical. In the name already is there. So what are the arithmetic operators in the Java? addition, subtraction, multiplication, division, and modulus. And what are the logical and or not? Right. So these are the performance operation has to be done in the ALU. The main thing is registers. This is very, very important. So this is the it is a memory. What is the meaning of register? There is a memory. You can see the TV, you can see the computer, you can see the radios. There will be a register, right? You can open that. You'll get if you see that, you'll get the different types of register. So what are the different types of registers? First one is PC. PC is program counter. In the name already there, program counter. What is the address of the next instruction? In the fetch, decode, and execute, I will explain how to use the PC. And what is the meaning of MER? Memory address register. It is going to store a memory location to the access. And the next one is MDR, memory data register. This is address register, and this is all the data being transferred. This is the memory location to the access. Next is CIR. Very important one is current instruction register, or the current instruction, whereas PC is all the address of next instruction to pass to the next, passing the signals, right? Yeah. And next one is accumulator, a very, very, very important in the last problems also. The meaning of accumulator, it store the intermediate results. So what are the values it is going to store in? And another one is their index register, and we have status register, IAL-AS, index register and status register. Okay, now I'm going to explain the fetch, decode, and execute. Very, very important for your board exams. Fetch. It is going to fetch. First, it is going to instruction from the PC to the MAR. What is the meaning of PC? Program to the memory address register. Okay. Next, memory address register to the is going to instruction register. What is the meaning of IR? That is CIR, not IR. CIR, current instruction register. Next, it is going to increment the value by 1, PC plus 1. Right. Now, in the fetch, these are all the topics. PC is equal to MAR. MAR is equal to, actually, MAR is equal to MDR. Next, MDR is equal to CAR. Next, PC plus 1. That is the fetch. Next, what is going to decode? Next, IR is equal to control unit. And this is the control unit, and it is going to identify the opcode and operand. And in the execute, who is going to perform the execute? We have arithmetical logic unit, and we have the different types of register, and the memory operation comes here. Fetch means these are the, it's going to read, and it is going to control, and it is going to perform the operation, and is going to execute the operation. Okay, first step is PC, program counter address sent to the MAR. Next, memory instruction sent to MDR. Next, MDR to CAR. Program counter to MAR, memory address register. Next, memory address register to the MDR memory. What is the meaning of D? It's a data register. Next to CAR. In the next is decode. Control unit is going to decode the instruction in the CAR. At the end, where it is stored, CAR, right? Okay. Next, step 3, it is going to perform the ALU, arithmetical logic operation, and results stored in the register. Where is the result stored? The register, the ALU, sorry, the ACC, right? So see, so this is the steps you are going to write. PC to MAR, MAR to MDR, MDR to CAR, CAR to decode, decode to execute. All these things are fetch. This is decode, and this is execute. You should write the same step. PC, program counter, MAR, MDR, and CAR. Got it? So this is 4 to 6 marks question you may ask. And what is the meaning of fetch? We're going to fetch all the instructions, and it's going to store in, where is that? First, starting from program counter means it's going to next instruction MAR, MAR to MDR, MDR to CAR. Next is decode and execute. Got it? Next, I'm going to explain fetch, decode, execute, reality example. Yeah, this one only. HF is preparing a recipe step by step. Fetch, chef read the next step from the recipe book. It is the fetch. Okay. Now CPU is getting the next instruction from the memory. Means next we have to use the PC plus one, right? That is the program counter. And the step two, just understand the chop onions. He understands you want to cut the onions, chop the onions. Next CP understand what action to perform in the decode and in the execute. Chef actually chop the onion. He's going to cut the onion. Finally, he got the instruction and CPU perform the instructions. So these are all the fetch and decode and execute. Got it? So this is a reality example. Want I can share the this one this notes. Next is the buses. So in the register, I would directly connect. No, by using the buses only. We have different types of buses. What is this? We have data bus. So what is the first one? Data bus. The name already is there. This carries the actual data bus. Address bus, it carries the address, memory address. Control bus, it carries the control signals. It's like a MAR and control bus means use that, what is that? It carries the actual data. Address bus, it carries the address of the memory address. Control signals, that is a CU. Okay, and address bus is unidirectional, only one way. You can't come the double way. Unidirectional, and the data bus is bidirectional. Address bus is only unidirectional, one point this one, and the data bus is bidirectional. Exam point of view. Okay, next one Newman architecture. If you know all these topics, fetch, decode, everything, one human also says the same thing. Concept is same memory store the both data and instructions, components, and CPU memory architecture. The same fetch, decode only. That is the one human architecture. You can see the textbook. You'll get to know PC to MAR to MDR to CAR, next to decode and instruction. If you want to increment the value means PC plus one. That is the one human architecture. You can go through it. What are the components in the this one? We have a CPU, we have a memory, we have input output devices, and we have a buses. And next is diagram identifier input. We are passing the input to the CPU, right? In the CPU, we have a memory, it's going to execute all that, and output, you will get the output. That you can see one human architecture. If you know the all fetch, decode, execute, that one is the one human architecture. You can go through it. Next, I can go to different types of buses. Or else I can download an image related to the white one human architecture. I don't have textbook. You go through it and you see the old year question paper also what type of questions he may form according to the Cambridge. This is related to the Cambridge, right? Yeah. Controls plus input. Yeah. I think in our architecture diagram, this one I can take. This one is. So don't worry. This is almost like a said control views. The same thing. This diagram I can take. Save the images. So you see the diagram here only input device, and the next is CPU control processing unit. We have the control unit, arithmetic register, PC, CAR, AC, MER, MDR, and we have the memory unit and the output device. This is the one computer. You can explain the CPU, all the units, and input in the CPU is going to process all the instructions, right? Control the signal, and the next one is the memory unit. This is the related to the your control unit and buses, address buses, and memory unit, RAM and this image. There's so many topics to discuss. Where is that diagram? Where it gone? That image you can store it in the right. That you can see the diagram. Now I can go to, instead of wasting the time. Uh, Input, CPU, memory. The CPU you can write on control unit. Next, arithmetic logic unit and the registers. Okay, now what are the different types of cables? Their syllabus. We have the first one is the first type of cable is USB, Universal Serial Bus. The name of it is there. It is a universal. It is the most common interface used to connect the device to computer. Right? If you want to use the computer or laptop or your mobile to computer, we can use the USB. You want to connect your TVs, we can use the HDMI. HDMI for the CPU to the monitor, right? VGA. Okay, what is the first one? USB is the most common used in the computer. And what are the purpose? USB, you can see in the keyboard. You can see the mouse also, pen drive, and the printer and mobile phone, right? The USB types of USBs. Type A, rectangular. You can see the rectangular port that will come in the port, right? That is the type A. After that, updated is type B, used for the printer. It is also rectangular, only for the printer. Next is USB mini. I think those were the what is that cameras. That will be the USB pin. That is for camera. That is mini. Next it is micro. After that it will come micro for our Android phones. Now the type C. Every time it is updating, the and type C is the modern one, right? So that is all different types of. And what are the features of USB? Plug and play. You can plug and you can play. Ama, door not door. And next is we can connect anytime, that we can use. It is a portable, right? Anytime we can connect, and it is going to support. It's going to send the data and receive the data along with the charge also, right? It is also chargeable also, but it is not a fully chargeable fast agalla, but it will be slow charging. USB is a which type of interface? Is a serial communication. That is not a parallel, it is a serial communication interface. Next I will go to HDMI, high definition multimedia interface. High definition, HD, so used for modern displays, and it's going to transfer audio as well as video. right? Another feature, it is in the digital signal. It is also HD and 4K videos used in the TVs and monitors and projectors, right? And that is HDMI cable only. I think you have this generation students, you know, what is the HDMI. HDMI carries both audios and videos in a one cable. Next is VGA. VGA we are using for the monitor to the CPU. VGA cable, video graphics array, it transfer only video signals. It not transfer the audio, whereas HTML transfer both audio as well as video, whereas the VGA supports only video signals. And it is another signal 15-bit emitter, and it is the older technology. VGA does not carry the audio. So these are all the three types: universal serial bus. Next is high definition. High definition, what is that? Multimedia interface, and next is video graphics array. Now I'm going to the important topic is interrupts. Interrupts means like a disturb. Okay, if as a student you're studying, okay, you're studying for the exam very seriously. One of your friend came and you disturb. Okay, 10 minutes we can go to play the cricket. After 10 minutes, again you are going to resume the study. That is known as interrupt. Interrupts means it's going to stop. That is going to not stop. Pause. Okay. What is the purpose of interrupt? An interrupt allows the CPU to respond immediately to the important events. It is a example. You're performing one operation and your CPU wants to perform another operation that is very important than the first task. Second task is very important first. Then you can pass the first task and it's going to the second task. Right. Avoid the waste and time checking device. Okay. Improve the overall system efficiency. Okay. Interrupt allows CPU to pause the current task to handle the urgent events and then resume the execution. The name already is there. What is the important instructions? Now you're studying example, second reality example, you're studying the very basic things. And you came to know that, hey, that is very important topic is the last page, you have a very important. Then you go to the very important task, you study everything. Next you come to the again the that is not very important. That also you'll study, but once you finish that, that is known as interrupt. Interrupt. It is going to pause the current instruction or current task and it is going to execute the very important or urgency or emergency. Next, what are the possible types of different types of interrupts? One is hardware interrupts. If generally external device keyboard press, you're tapping the press keyboard so how many times there is a chance of interrupt. Mouse click. If you click on that, it's going to interrupt, right? Next, printer and this one. Next is what are the different types of software interrupts? Division by zero. If a number is divisible by zero, what is the answer will come? Infinity, right? It will keep on running. That is also another type of interrupt. If you are given the invalid, logically error, invalid instruction, that is also software interrupt. Next is applications of interrupts, input output operations and real-time systems and multitasking systems and error handling. These are the different input output CPU response when the device is ready and real-time traffic controls. There also you can use the traffic control signals. Traffic also you can see it keep on changing lane. After 60 seconds it will go to the next traffic. Keep on running. And what are the applications and multitasking? Multitasking means you have more number of tasks, more than one task. Okay, among that, which task is going to execute? All this thing has to be done by the CPU. Means the operating system, the CPU, it is going to perform which task has to be first. And next is error handling. In the error handling also, which task, which error has to manage first. So what are the different types of application of interrupts? Input, output, real time, and multitasking, and error handling. Multitasking, how CPU is going to switches. What is the meaning of switch? It's going to switch from the one task to another task. And error handling, that is also efficient multitasking and real-time processing. That is the main thing. Next, we have ISR, Interrupt Service Routine, is a special program that executes when an interrupt occurs. It's going to execute when an interrupt occurs, and it all handles the specific interrupt. The topic is not complete, is not there. That is a different topic. Just he has given ISR. What is the full form of ISR? Interrupt Service Routine. What is the role of ISR? Identify the interrupt source, where the interrupt starts, where the disturb or where the pass starts, and perform the required action. And it's going to send the acknowledgement and returns the control values to main program. ISR is a predefined routine that handles the interrupt and allows the CPU to resume to the normal exception. So that is a special type, and it is going to check which is the interrupt source, and it is going to perform the required action, and it is going to send the acknowledgement, and it is going to return the control to the main program. Right. So it is nothing but it's going to find the interrupt, and it's going to perform the action. It is the interrupt service routine. Next, we have when the interrupts are detected. This is very, very important. That the interrupts are checked at the end of each fetch, decode, execute cycle. At the end of fetch, decode, and execute cycle, you can detect the interrupt, meaning CPU does not stop mid instruction. It completes the current instruction first, then it is going to. Okay, now the important topic is step by step. Okay, an interrupt signal is received. If you got the input, that interrupt signal is received, CPU complete the current instruction. It is running the one task is complete. CPU check for the interrupt. Now, once it is finished, it's to check for the current what is that interrupt check for. Next, current state is saved in the memory task, and CPU jumps to ISR address. If you after receive the interrupt, will jump to ISR, interrupt service routine, and ISR is going to execute. Once it is accept the interrupt, ISR is going to execute, and CPU restore the save data, the first task, and CPU resume the original program. It's a simple thing. You can take the reality example, then you'll understand. And when interrupt is comes means ISR it will come, it is going to execute, and it's going to restore the original, and restore the original problem, original task. Simple flow, normal execution, interrupt comes, ISR it will come, it is going to execute, and it resume. If you know all the steps, it is the conclusion. Right. Example, while you are eating the food, you get one interrupt, you get one small stone. What you will do? When you give call to ISR, ISR is come, ISR means interrupt service routine. It is going to remove that stone. Okay, in the reality example, after that you will again start to eat the food. It is known as interrupt service routine. Next, I will go to reality. Teacher teaching in the class, fire alarm rings, interrupt, start teaching, handle the emergency, what are that ISR, and resume the class. That is also as a teacher, right? Finish, save, jump, execute, restore, and continue. First, finish the current instruction, and you can save all the instruction to this memory, and it's going to jump to ISR, and it's going to execute the ISR, and it's going to restore the original task, and it's going to continue, or it's going to resume the task. That it. This is the related to the interrupts. Next, we have two pass assembler. We have one pass assembler and we have two plus assembler in the assembly to convert assembly level language into machine level. So you are convert assembly level as computer is understand only machine level, right? 0 and 1. The writing instruction in the assembly, then now who is going to convert? So first we have the first one pass assembler, pass 1 and pass 2. In the past one, assign the address to a labels. So what is the address? Example, apparent you are giving load. That value you are passing to the labels. In the two pass assembler, that label values is going to convert it into the machine code. Okay. Example, reality example, assign the address to label. Now, reality example, if you want to building a house, okay, you want to build a house, you have a blueprint, right, to create the house. You have to check where is the kitchen location, where is the bedroom location, where is the hall position. You will do the labels. That is the pass one. And the pass two, the pass one, we have assigned address to the label. In the pass two, I am going to convert it into machine code. So assembly is going to convert it in the machine code in the pass to assembler. And here you are going to actually build the face, use the plan from the pass one, right? Pass one means what is the labels that based on that you are going to do the plans to. Pass one, where is everything, and pass to convert to binary. Binary means 0 and 1s. That is the pass one and pass two assembler. Main task, feature main task, identify the label, generate the machine code, and the output, it's going to create the symbol table and it's going to generate the final machine code in the form of 0 and 1s. I hope this topic is you understand. Next is so these are all the fetch, decode, execute, one human architecture, interrupts, types of assemblers. Next we have in the last class also I discussed LDM, load immediate address, load the number immediate number directly into register. If you are passing 5 here to R1, 5 is stored in the R1. Just pass the number straight. Next, load the direct LDD, load the direct. It goes to 100 means go to memory address R1 100, go to the address R1, R1 to 100. In the 100 memory address, that is going to copy to the R1. Yeah, this is direct. Immediate means the same value is going to convert, it is going to take. Here, address is going to convert. Next is LDR. It's a indirect. Load the address stored in the another register. R2 value that is stored to R1 value. What happens? R2 contains example 200. Go to the 200 space, 200 the memory location. That value is passed to the R1. Load the value into R1. Already I have done this one in the last session. And the indexed is here base address plus index. It is going to take R1 100. Take a base address of 100, add the value in the R2 in the register 2. Finally, you will get the 103. How it is 103? 100. Example, it is R2 value is 3 means 100 plus 3 is 103. That R3 value you can pass to R1. It is the indexed. So you're going to add what is the value in the R2 also. It is indexed. So R1, sorry, this value 100 plus R2 value. And these two, after that you perform this one. Next it will go to store in the, it's going to load in the, not store, load in the R1 number directly, exact location. It is going to point to the reverse, right? And it is the address plus register and array access. M stand for immediate, D stand for direct, R stand for register, R else indirect, register access, and X stand for index. Now I've taken another one example. In your yeah, this is 2024 question paper. Wait, May June 2024 paper set 3. Okay, everything you can practice, you will get to know one by one by one. Question number 3. So what is that? He has given M immediate address, D direct addressing, LI indirect address, X index addressing, R is immediate address, node number, N into the index register, add, decrement, sub increment the value. A stand for binary number, B stand for binary number, and ampersand stand for hexadecimal number. So he has given the current instruction 48, the value stored 51, in 49 the address 6 is given, and the current and accumulator value is 2 and index register value is 50. So now you have to perform one by one. The first program counter PC code is LDM, immediate address. In the 50th value, what is the value stored? 50, 48, right? And now that one also I have taken. We have three steps, step by step. 50 directly I can take 50, right? What is a which type of address? It is the immediate address that you can take directly 50, right? Not in the 50th value, I'm going to take 48. No, if it is a LDD, you can take 48. It is a LDM, immediate address, you can take 50. Increment the accumulator. What is the accumulator value become? Accumulator value become 50 plus 1, 51. Right? 51. Okay, next. Next it is subtract by 1. Next, 51 minus 1 means 50. At the end, you will get the answer 50. What is the accumulator value become 50. Okay, now what is the next instruction? LDI, indexed LDI and indirect, right? LDI is indirect. Now, LDI 51, 51. In the 51, the 51, what is the value stored? 51, 50, right? See that? In the LDI, second step, LDI, indirect, that is indirect. 51, value stored is 50, right? It will go to 51 in the 50. In the 50th value, okay, now in the 50th value, what is the value stored is? It will take 48. It is an indirect. It will talk to the R2, that base address it will go. The 50th value, what is the value stored? 50, where is the 50? 48 it will come. The first step, 48. And next step is add 52. The 52, what is the value stored? In the 52, we have 49. So it is going to add. It is not going to add the 52 directly. What is the value stored? Data is stored. So 48 plus 49. 40 step 2, 48 plus 49, it will go to 97. So what is the updated value here? 97. Can you get there? 47. And next is LDR, 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 AS2. AS2 means the binary number 2. That is going to do step program number 3. LDR, AS2 means index register is 2. Right. And the step 2, index address, as we know, index register 50 plus 2 means it will go to the 50th register address plus ix 50 plus ix value is 2, right? 50 plus 2 is 52. Okay, now 50 plus 2 is 52. 52, what is the value stored in the 52? 49. 50 plus 2, 52. In the 58, what is the value stored? 49. We want to take the 49. Next to 49 minus decrement means it is going to decrement the value by 1. So it will decrement the value by 1 means 52 and the value stored is 49, right? Yeah. And the 49 minus 1 is 48. So what is the updated value you will get here? 48. 48. And the next is load DD, direct addressing. This one you check. This is MEDD. In the 52. In the 52, what is the value stored? And now we'll take 52 or 49. This direct addressing, so you can take 49 directly. 49 and subtract 52 in a 49 and subtract 54. In the 54, what is the value stored? 6. So 49 minus 6, 43. Next, increment the ACC. 43 plus 1, 44. 44, yeah. Where is that? Load 52, 49. Directly can access 49. 49 minus 6 is 43. 43 plus 1 is 44. Right? So you'll get the 44. So these are all the types of problems you can expect in the logical assembly instruction set. Now I can go to another one question. And means if both are one, you will get a answer one. In all other condition 0. XR means any one is one, you will get one. Both are one, both are 0, 0. And R means anyone is any both are 0 means you will get 0 in another condition 1. And logical shift left and logical shift right. Logical shift left means you can pass the left values and you can pass the right values. Now we done. Okay. Now I explain the one problem. It has given 100 0 0 0 0 double 1 double 0 1 and yes beyond the values some value and the current content of the accumulator you will give 1 1 1 1 8 ones. Okay, now our task is to do, you can take this one as a complete the table by content of accumulator of each structure run. The binary one is reloaded into the as before instruction is run, so it's not going to update. For each instruction, you can take the input is 1111 updated value. Okay. First one is as given LSL. For this one 111 left shift 2. You can shift the bit to the left 2 times, 2 bits. Okay. Now you can see here. For that one also I have taken bit shift to the left. So what is the first one? All the values are 4 ones, 4 ones. I will take first one is, and now I am passing left. The video it will show the whole time. I'm passing the values to the here. First one is I'm passing 0 here, 1 1 0, and I'm passing 2 0. Left shift. If it is right shift, it will come here. It will come the value from here. It will go to the values to here. It is a 0 and it is a 00. Left shift 2. LSL 2. Okay. And the next question is XR 100. So in the 100, what is the value is given? 100, 4 zeros, 00, 11. And you can take the accumulator value 1111 Don't take the updated value of this accumulator because he has given is every time it is going to reload. You can see the question properly. So the second one is XR. So what is the value stored? It is accumulator is all the 111 and in the 100 is stored 401101. As I said, XR means if both are 0, both are 1, you'll get 0. If anyone is 1, 1. 1 1 0 1 0 1 1 1 0 1 1 0 1 0 1 0 1 1 0 1. Andre, I mean if both are 1, both are 0, you will get answer 0. In all other condition means 1 0 0 1, you will get the 1 1 1 1. And next is AND. AND is nothing but multiplication as we know. If both are 1, 1, in all other condition 0. 1 1. 1 1 into 1 1 1 into 1 1 1 into 1 1 1 into 0 0 1 into 1 1 1 into 1 1 1 into 0 0 1 into 0 0. And I have taken, and as mentioned, 103. 103 means 103. What is the value is taken? 0011. You have to take. So what is the first input? Accumulator, and the second input is for XR in the 100 value. What is the value? And in the for this AND instruction, you have to take 103. and you can perform the operation. This one you will get the answer. So this is double one double one double zero, sorry, double one double one double one double zero, double one double one double zero one zero, double one double zero double one zero one double one. So these are the questions in your board exam. I hope it will be useful and you can see the question paper. So almost I have finished all the topics in the computer processor fundamental chapter number 4, along with processor fundamental, CPU architecture, assembly language, and bit manipulation. Bit manipulation is nothing but the last one, and XR and R and logical shift left and logical shift right. Logical shift I will explain in lesson. You can go to the logical shift right also. This is the question topics I finished. I hope it will be useful. If you have any doubts, you can send the mail or send the and share it in the comment box. Uh, Thank you. Can next class and next session I'll create another one DBMS questions, and next I'll directly go to this how to read the algorithms and algorithms as well as the flowchart and pseudocode. And these are the another topics, majority of theory topics. You can go through it. Data security and this one. And don't forget to do the this one network chapter. Network chapter is very, very important for your board exam. IPv4, IPv6, subnet task, and the chapter number 1, different types of data, image, text, sound, and different types of text, ASCII code, Unicode, and different types of compression, lossless, lossy, and different types of networks, LAN, WAN, MAN, and types of this one, bus, star topology, topologies, and what are different types of logic gates, where AND R, XR, XR NAND gate, and logic circuit, and CPU architecture, and what is the meaning of operating system, is the interface between user and the software, and what are different types of system management, process management, task management, and what are the language translator, compiler, debugger. You can go through it. And data security and integrity, data consistent, and ethics and ownership, and DBMS. I will discuss. I will discuss the DBMS. I will take time and explain clearly what are the DML, DDL, and how to write the queries. And you see the all the question paper, you will get some ideas. And as we know, Cambridge IAL level is what is it? Everything is analytical based questions, conceptual. We're not going to mug up anything here. You know all the topics. That's it. And IPv4 memory size, memory bits, IPv6 subnet mask. You can go through it, and different types of cables, USB, VGA, so all these things. And next I will after that I will go to, and in the software development also, what is that? We have discussed. What is that? Waterfall model we discussed, right? So it is going to system requirement, and next we have development, design. First design and requirements, and next is we are going to development phase. Next testing phase. Next is system maintenance phase. All these things, and we will discuss. I will create some more videos day by day, day by day. I will create it, and thank you. You can see the video. It will be very useful, I think. Thank you.